Alright, in this little two-lesson module, we're going to take what we've learned about analyzing trusses and apply them to a slightly but very similar situation with what's called machines and frames. So let's take a quick look here at the kinds of systems that we're really talking about. With trusses, we ended up with everything being, see down here, everything being members that went from joint to joint to joint, and all the joints were pinned. And so with the loads being applied only at the joints, that meant that we ended up with a whole series of two-force members. Right now, two-force members don't have to be just straight. They just are typically in trusses. They can be any sort of object that has just only two pins, and that's where effectively the member gets loaded. Now, if we have members that have three forces applied to them, then we'll have a concurrent force system because all three of these have to pass through a common point. If two of them pass through a common point, as would be the case, the third one, if it didn't, would tend to spin the thing. So that's got to be a concurrent force system, and we're going to see a lot more of these in these machines and frames. We never saw those in the trusses because everything was just two-force members. Right? And that's what leads us to taking a look at all these machines and frames you see in this next page. This excavator has big oblong members that have hydraulic cylinders located at various places. Each of those cylinders are connected by pins only at their ends, but the members themselves are not necessarily straight, and they're also not of a constant cross-section. This engine hoist has several members here. We got the loading beam here, that where the engine can then slide along the track of that thing. We've got the hydraulic cylinder AB, but note this GAC member is one long continuous member. It doesn't go from joint to joint, but is one long continuous member. Same thing with CBD, one long continuous member, and this hydraulic cylinder is connected in between them. That helps provide the stability for that one. And then we have a moment resisting connection down here at D for that vertical piece, and then we have the horizontal piece that comes out, and then the two wheels that are attached. Right, so a lot differently constructed than what we see with trusses. These pliers have then a solid piece that comes up and then swings around. It has a variety of pin connections in it, this upper grip, same kind of thing, and then there's actually two horizontal pieces. So there's actually 1, 2, 3, 4 pieces in the pliers that we have here. Some pliers are just two pieces. This is a 4-piece plier, these horizontal pieces that actually form the grips. And then we have this frame straightener. Same thing, a lot of pin connections at various places, solid pieces in the X, solid pieces horizontally in the top and bottom, but the members do not go from just joint to joint. So wrapping this up here, the similarities, pin connected members, trusses have loads applied at the joints only, the frames and machines have loads can be applied anywhere, and the members don't have to be straight. The consequence of that is what you're going to see over here on this page. Right, that trusses two-force members either in tension or compression only, but in frames and machines, our members may be subjected to a combination of axial shear and bending. So depending on what this member might look like, it could be straight, that would be fine. And so what this means to be axial is axial tension or compression. Tension, of course, is shown. You could have bending being created. That would be our bending moment. And then here's our shear forces that might come along this. And of course we might have applied loads that are imposed upon the member at various places that help to create this bending and shear force situation along then with our axial force condition. Right? So in our analyses that we're about to go do, that's going to be partly the big impact or big difference here. The free body diagrams of the members may be a lot more complex than what we saw with the truss. Well, not maybe, most certainly will be more complex. Right? So in the next video we'll start looking at how to draw free body diagrams.